This is very important, actually. So important that you will use it in grade 12 as well. So I want to teach you this properly. So that previous stuff was just basic grade 9 or 10 stuff. Now we're getting to some grade 11 stuff. Basically, you need to memorize these two triangles. So if I were you, I take a screenshot or, pause it and copy it whenever you watch the video, or take a picture quickly, because these are called special triangles. And these special triangles are used for when we want to determine the exact value of something when it comes to trigonometry. So the exact value means that I cannot write the answer in a decimal form. So a lot of students who like to use their calculator and just like plug in, sine of like say 45 degrees, and you'll get a decimal answer. You just write the decimal answer. Well, you wouldn't get any marks if the question is asking for exact value. Because exact value, you have to write it in terms of a radical and a fraction. Sometimes just a radical, sometimes just a fraction, sometimes it's equal to a whole number. So that at that point, you probably could just use a calculator. But yeah, so how do special triangles work? Well, there are two special triangles. One is the 45-degree angle triangle, and you should memorize this. Very easy. You have a right angle triangle with both angles being 45, and the third one being 90. And in this case, the side lengths are 1, 1, and square root 2. Pretty straightforward, very easy to memorize. And all you have to do is now write the three primary trig ratios, the SOHCAHTOA equations, for this triangle. So sine 45 is equal to opposite, which is 1 over root 2. Cos 45 is equal to the adjacent, which is also 1 over root 2. And tan 45 is opposite over adjacent. So opposite is here, adjacent is here, 1 over 1. Tan 45 is equal to 1. So that's your three equations that you can get from this one triangle. And you have to memorize these. Or memorize a triangle and you can just write them. Second, we have another triangle. And this triangle has specific angles of 30 and 60 degrees. So if we are labeling our angle as 30 degrees, the opposite side is now 1. The hypotenuse is always 2, because that's the longest side and it's the side across the 90-degree angle. And this side here, the root 3, is our adjacent side. How is this the adjacent side, you say? Well, remember, the angle we're looking at right now is angle 30, not angle 60. If you're looking at angle 30, the opposite side is the 1. Be very careful with that. This is a lot of students always think that, oh, the height is the opposite side. No, that's wrong. It always depends on your angle that you're looking at. So sine 30 is opposite, which is 1, over hypotenuse, which is 2. So sine 30 is equal to a half. Cos 30 is adjacent, which is root 3 over 2. So that's root 3 over 2. And then tan 30 is 1 opposite over adjacent, 1 over root 3. So these are your exact values when it comes to the 30-degree angle. So if I were to write this or punch this in my calculator, if I were to punch cos 30 in my calculator, what would I actually get? I'm going to do this right now. I advise you guys to do this as well. Get a calculator, type in cos 30. Some of your calculators will give you the exact value. Some calculators are actually very smart. Most calculators, however, will give you this answer, 0.866. If you get 0.866, this is the correct answer, but this is not the exact value. This is wrong. Cos 30, the way to write exact value is root 3 over 2. And that's just something that you need to, understand. That you cannot have decimal value answers if the question is asking for exact value. If the question doesn't say anything about exact value, then just write 0.866. You're okay then. All right, and then from the same triangle, we also have a second angle, which is angle of 60 degrees. But if I'm looking at my angle from the eyes of 60 degrees, my opposite side is now going to be root 3, because that's the opposite side. My hypotenuse doesn't change, so that's obviously going to be 2. And the 1 in this case is going to be my adjacent side, because that's the one next to 60. So now sine 60 is opposite, which is root 3 over 2. Cos 60 is 1 over 2, because that's adjacent. And tan 60 is root 3 over 1. So be careful when you're dealing with angles and which exact angle you're looking at. And make sure you don't mess up the triangle. So try to figure out a way to memorize this. 1, 2, 3. 1, 2, 3. 1 is, on the bottom, 2 is on the hypotenuse, root 3 is on the side, and then figure out where the angles go. Usually 30 degrees has the root 3 next to it. All right, so that's that. Those are special triangles. How do I use them? I will show you exactly now. So I'm going to try to go very fast in this because I want to cover as much as possible. The rest is up to you. You guys will have to watch the videos and look at the notes and whatnot. Okay, so determine the exact value. Keyword here, exact value. So as soon as I see that in any question, when it comes to trigonometry, I know I got to use special triangles. So the first thing I would do is probably draw my special triangles. I've got, okay, hold on. I got a special triangle of 45 degrees. That's the easy one. Oh my gosh. $45, and I know my sides are 1, 1, root 2. Very easy. And then I got another triangle. It's a little bit kind of, like this. And I should draw it here because I'm going to need that spot later. All right, so, and this triangle, sorry, it's not completely 100% right. I should probably change that just to make it at least a little bit better. There you go. So this is my right angle triangle, and it's going to be 1, 2, 3. I know that. And I know that 30 degrees is next to my 3, and that means this has to be 60 degrees. So this is my special triangle. Now, let's do this. So sine 45. Sine 45 is going to be opposite, which is 45. Opposite of 45 is 1, or hypotenuse, 1 over root 2. So I know that sine 45 is just 1 over root 2. That's what that becomes. Cos 45 is the same triangle, but it's actually the same thing because it's 1 over root 2 adjacent over hypotenuse. So that's just 1 over root 2. So these two brackets just simplify to these two fractions. Now we have a plus sign, so don't forget that plus sign. Sine 30. Sine 30 is going to be opposite, which is this guy here, 1, over hypotenuse, which is 2. So sine 30 is just going to be a half. That's what that would just do. And sine 60, remember, 60 is here. So opposite of 60 is now root 3, and hypotenuse is 2. So opposite over hypotenuse. So all of these brackets simplify to these fractions here. Now we multiply. What's 1 times 1? That's just 1. And what's root 2 times root 2? And if you do it correctly, it's actually 2. And that's something that you should know. That root 3 times root 3 is equal to 3. Root 10 times root 10 is equal to 10. So if I have the square root of a number multiplied by itself, it just gives me the number that's inside that radical. And you can do the math. You can figure it out yourself. You can use the calculator too to prove this stuff. It's not that hard. And now 1 times root 3, that's just root 3. And 2 times 2 is 4. Remember, when you're multiplying fractions, you just multiply the top and multiply the bottom. Now we're adding these fractions. So we need a common denominator. Obviously, I'm going to multiply this by 2, the both top and bottom. So that's going to be 2 over 4 plus root 3 over 4. Now that I have my common denominator, I can combine the numerator like that, and this is the final answer. 2 plus root 3 over 4. That's the answer. So I started off with this, and I ended off with a fraction. And we can take a look at the answer. It is 2 plus root 3 over 4, and we're good to go. One more example before I move on. Okay. So same thing here. We have sine squared 30. Now, don't be confused with that square. Sine squared 30 is the same thing as sine 30 times sine 30, right? Like, don't be scared of that. 1 minus cos 30. And they're asking for exact value. So what is sine 30? I know that sine 30, well, here, if I draw my triangle here, And I know that, I should probably move the triangle.